Okay, so as quickly as I can, I want to talk about, well, Hermeneutic Circle or the hypothetical-deductive model of science. Hermeneutic Circle comes from hermeneutics, which is social science, a study of human beings, and hypothetical-deductive method comes from the natural sciences. But there's a deep similarity between the two. Let me start historically. During the Protestant Reformation, people were trying to find a way to read the Bible the right way, to find out the truth, capital T, about the Bible. And one very important theologian who tried to do this was Friedrich Schleiermacher. And Friedrich Schleiermacher is maybe the founder of contemporary hermeneutics. Hermeneutics, people tell me, comes from the name of the Greek god Hermes, who was the messenger god. So hermeneutics is a philosophical subject that deals with art of interpretation. And so what Schleiermacher discovered is that if you want to read the Bible, if you want to understand the Bible, you need to already have a theory of the Bible, that your understanding of the whole enables your understanding of the part, and then your understanding of the parts modifies your understanding of the whole. This, in many ways, even though I just said it, associates with Schleiermacher, but this kind of goes back to Plato, Meno's paradox. In order for you to learn about something, in some sense, you need to already know about it. They are, Meno and Socrates in the dialogue are discussing, I think, looking for some particular person, and it's like, how would you know that you have met the right person in an important sense before you know what counts as the right person? Or it's like, again, you open the Bible, you need to have already an understanding about what is a book, what are words, what are sentences. So before you even open the Bible as a book, you need to have an understanding of the whole of the Bible. Language does not interpret itself. Like, unless you already know how to speak a language, in some sense you cannot learn a language like from nothing, from scratch. Because and it's, evolutionary, in terms of evolution, it's true. Human children are able to pick up human languages, as far as we can tell, because we have a neuronal structure. Like, in some sense, Noam Chomsky calls this language acquisition device. To some extent, language, at least the basics of language, are pre-programmed into our head. So very, very tragic, but also very famous stories about how children who find themselves in times of crisis can develop a language in a single generation. So it's like, I'm oversimplifying, 2 kids abandoned on a desert island, if they survive, will invent in a single generation a language which is much richer than anything that animals have. It's amazing, but it's true. Again, there's this neuronal structure. If you want to ask me during the break, I'll tell you the details of these very tragic circumstances under which these things have been observed. Anyway, so this is hermeneutics. This is hermeneutics, and it's notice this is part of the story, rehabilitation of prejudice. Again, from Schleiermacher to Martin Heidegger, who talks about this in his Being and Time, to his student Hans-Georg Gadamer, right? This idea that before you can understand anything, you need to already have an understanding of the whole. And Heidegger talks about how you make choices in life, but on the basis of the things you do not choose, right? So it's like, this room makes sense to me because, among other things, I feel subconsciously that I'm going to die. And the world matters to me, right? So it's like, I have a predisposition to understanding the world in a certain kind of way, and that's why this room makes sense. Anyway, this might not have been very clear, so let me switch gears. This is the so-called Hermeneutic Circle, and it's a vicious circle, and it talks about how, in some sense, again, before you know something, you already need to know it, and it means you always have to rely on assumptions with which you find yourself, and you can never really ultimately verify these assumptions. And again, for me, this would be homologous to although I'm not sure if it's logically homologous, but in my head, philosophically, this is homologous to Gödel's incompleteness theorem. And Gödel's incompleteness theorem basically says that any kind of logical system that's worth anything, let's say a logical system that can generate arithmetic, any logical system that is at least powerful enough to generate at the very least arithmetic has to contain assumptions which can never be proven within the system. It's very interesting how he uses logic to undermine logic. It's a logical theorem. Gödel proves that it is impossible to prove a logical system which is good for anything. Basically, I'm oversimplifying, but still. Now, what is hypothetical-deductive method? What is hypothetical-nomological method? Hypothetical-nomological method talks about how you begin with a theory, And it's similar. A theory is the understanding of the whole. You have an understanding of how the world works. And then, it's very important, in your theory you have concepts. And concepts you cannot observe, like temperature, for example. You cannot see temperature. So you need to operationalize your concepts. You need to have indicators for your concepts. So for example, you're going to say, I cannot see temperature directly, but I will take a measurement of the thermometer as an indicator of temperature. Notice, the measurement on the thermometer is not temperature. It is an indication of temperature, but it's not itself temperature. For example, thermometer could be broken, could be showing something which is kind of not really temperature. So theory, and then you do observations, right? So, but observations need to connect to a theory through operationalization, right? Observations by themselves are blind and meaningless. It's like, it's like imagine showing to a hunter-gatherer a thermometer. No, they see maybe a hunk of shiny metal. They could say it's cold, but they do not understand what it is for. You need to have a theory of thermometers for thermometers to make sense. And then what you do is, once you have observed, you have to generalize. You have to generalize and you have to feed it back into the theory. There's no such thing as a raw observation, because there's always, for example, there's always observational error. Like again, it's like you say it's 20 degrees. Well, is it exactly 20 degrees? Maybe 20.01, maybe 20.01.0001, or it's like, if you take a temperature measurement very often in sciences, you do like 10 or 20 or maybe 100 temperature measurements. But which one do you choose? Maybe you pick an average. But why do you pick an average? Maybe you use some kind of statistical devices. Maybe you throw out the outliers. But you see, you need to have a theory. So it is a circular process. And before you can observe, you need to have a theory. And it's a vicious circle. Again, it's called hypothetical-deductive method because you use a theory to deduce from a theory a particular prediction, and then you use the observations to test the theory. But observations are theory-laden. Observations are not independent of theory. Observations exist only when they are informed by a particular theory. Okay, I'm rushing through this, but I want to get this out. So it's like, in the 20th century, there were these three big movements in philosophy of science. The first one was logical positivism. And the positivists hoped that you could simply take data and generalize data. It's like, the logical positivists were very impressed by the Einsteinian revolution, and they were impressed and upset by it, because people for more than 100 years thought that Newton had the truth with a capital T. And then it turns out, no, he didn't. Einstein proves, at least with a margin of error, that Newton was wrong. There are certain things that Newton cannot explain, like the precession of the perihelion of Mercury, right? There's all sorts of other discrepancies such like these. And so what logical positivists wanted to do is they wanted to find a robust way to generalize observations. And their approach failed for many reasons. One reason, because if you take a graph and you plot some points on a graph, you cannot just use points to generate a function, because you can generate an infinite number of functions for any finite set of points. So observations do not automatically give you theory. You can say, it could be this, could be that. So you need to guess the theory in some sense of process. Einstein didn't generate theory of relativity from the data. In some sense, he imagined it creatively, like a poet writes a poem. It's amazing, right? So this is one reason logical positivism doesn't work. And the second problem is, again, that observations are theory-laden. Something counts as an observation only against the background of a theory. It's like, you see, Galileo sees the moons of Jupiter. This, for reasons I don't want to go into, this goes against Ptolemy. Within Ptolemaic astronomy, Jupiter cannot have moons, for reasons I don't want to go into right now. Ask me during the break if you want. And Cardinal Bellarmine looks through the same telescope and says, Galileo, I don't know, I see some blotches of light. It's, your telescope is not very good, it's not very clear. I see something, but I have no idea. You say these are moons of Jupiter, but maybe it's just something in the atmosphere. Maybe it's dust in the clouds, or maybe it's dust in your lens. See? An observation counts as an observation only against a theory. It's like Galileo has a particular theory of how his telescope works, and therefore he concludes that Jupiter has moons, and therefore moons of Jupiter orbit around Jupiter and not around the Earth, so the Earth cannot be the center of the universe. And Cardinal Bellarmine says, I just see, faint, blurred blotches of paint, and thank you very much, or blotches of light, thank you very much, says Cardinal Bellarmine. I'm going to stick with my biblical worldview in which the Earth is at the center of the universe. They have a different theory. That's why the same observation is interpreted differently. So logical positivism doesn't work, because observations are dependent on theory. It's called theory-ladenness of observation. The second approach was by Karl Popper, and was called falsificationism. And Popper Popper said, well, you can never prove your theory right, but clearly you know when your theory is wrong. So maybe, again, you could say that it's like through this line, through these points, I can draw an infinite number of different lines, but very clearly, like this line or that line, well, you understand, right? So you can through the same finite set of points, you can draw an infinite number of functions. But Popper says, but at the very least, I know exactly when my theory is false. So for example, if my theory is that the function should look like this, and the observations look like this, I know that at least my theory is false. So Popper is going to say, I cannot know the truth, but at least I can know falsehood. And the problem with this is that you can always wiggle out. And again, Popper also doesn't work. So it's a nice story. People had hopes, but in fact, that's not the way it works. It's like, again, when people saw within Newtonian picture that Mercury doesn't follow the predicted orbit. They did not throw Newton out the window. This is not what they did. They said, well, maybe your telescope is not accurate enough. Maybe it's some kind of an error. Or maybe there's another planet called Vulkan. It's so close to the sun that it's invisible through the telescope. Today we have the same problem. 95% of the universe is completely mysterious to us. We call it dark matter, dark energy, because we don't understand it. Because, again, if you take the points in the sky and you plot them against our best theories of Einstein and of standard model of particle physics, we can only account at best for 5% of the things that we see around. And the rest, 95%, we say are Vulkans, things that we cannot see, right? So, you see, Popper thought that you falsify, and that's the end of the story, but in fact, no, you can always, it's called auxiliary hypotheses, or you can talk about ad hoc assumptions. Auxiliary hypothesis, ad hoc hypotheses, you can always wiggle out of any observation. You could say, well, it was a fluke because, it's like, again, imagine somebody gets a shot against COVID and then they get COVID. We can always say, well, maybe the shot did not work, the medication, like the container was breached and was not the proper vaccine. But in fact, vaccines work. But in this particular case, it didn't work, not because vaccines don't work, but because this particular vaccine was spoiled. You see, you can always do that. Or you can say, look, it's really hot in here. You show me a thermometer, and the thermometer shows it's cold. And I say, no, your thermometer must be broken. Huh? So auxiliary hypothesis, it's like flat Earth, which is a complicated and a bit of a dangerous subject, but the flat earthers would say, well, the Earth seems round from certain angles, but that's because it's only some kind of illusion, optical illusion, or maybe a conspiracy, right? But you can, if you're willing to work hard enough, if you're willing to introduce additional assumptions, you can always wiggle out of any observation. And at the end of the day, again, you see, with Gödel and with Heidegger and Schleiermacher, we know that our thinking cannot be without assumptions. And by choosing different assumptions, you can make any theory work. In fact, if you're willing to believe that the Earth is flat, if you really want to work at it, you can even make it work. So the only approach that is left standing at the end of the day is something I mentioned already, is approach by Thomas Kuhn. Thomas Kuhn, who's going to say that science is sociological. We have a sociological consensus. You have a theory, I have a theory, and we discuss, we debate. It's a human thing, it's a human process. And it involves grants, it involves prestige, it involves honor, it involves old people with a lot of money, it involves, young, ambitious scientists, and it's a game, it's a political game, politics of truth, sociology of truth. And we hope that for pragmatic reasons, if your theory is really horrible, then your rockets fall down and your people get diseases, and so at the end of the day, there's some hope that we're moving towards the truth, but there is no guarantee. There is no guarantee, and again, I will remind you that for the vast majority of it's like for large chunks of human history, the medical interventions that people did, like bloodletting, for example, were patently bad for the patients. And yet, despite all potential evidence, the doctors continued to practice medicine, which was really bad. And like your chances, as far as we can tell, of getting well, for example, were better if you stayed at home than if you approached the doctor. So there's hope that we're moving in the right direction. But it's only a hope, and it can never be really proven. So again, the reason I bring this up, and this is going to be the last sentence I say, the reason I bring this up is because in this course I'm giving you a very ambitious story from protons to presidents, and I am passionate about this story. I am deeply passionate about this story, and I advise you to take it very seriously, this story. But at the same time, we have to understand that at the end of the day, this story is not built on anything like firm foundations, but more like built on sociological consensus, which is where the two courses that I teach, philosophy of science and political philosophy, coincide. Okay.